Okay, so now we can start our little review here on forces. So that's right. So the first step we need to do is to find the acceleration equation. So to find the acceleration equation, we need to take the force and divide it by the mass. Okay, so in this case, we've got to divide everything by 0.2 kilograms. Okay, so that would make my acceleration function 3 divided by 0.2, that comes out to be 15. Can you guys get your calculators out, please? 3 divided by 2 will make this 15t. What about 0.5 divided by 2.5? So that's going to be minus 2.5 t squared. Okay. Meters per second squared. Okay. All right. Then, if that's my acceleration function, how can I find the velocity after 3 seconds? Or let's do this. Let's find the velocity function first. How would I go about doing that? Okay, take the antiderivative of this. So for 15t, I would get what instead? Okay, 7.5 t squared. Okay, and then for the next part, we just make a fraction out of it. Okay, 2.5 over 3 times what? T cubed, and we need to evaluate that from what to what? 0 to 3. Okay, I'm assuming you guys can all do that, so I'll just, if someone wants to calculate out the answer and give it to me in a minute, that'd be great. Okay, so that's how we found the velocity function. Okay, what about the position? Okay, does it ask? Oh, no, it just asks for, yeah, it asks for the position too. No, because we're going to subtract it from 0 there. Okay. All right. So, okay. Now, to figure out what this would be for the for x, okay, how would I go about solving it for x? What would be the position function? How would I go about doing that? Okay, all right, so tell me how that would turn out. Okay, 7.5 over 3 times what? T cubed. Okay, and I'm going to subtract, what is it, 0.208 t to the 4th. Okay, and then I got to evaluate that as well from 0 to 3. Does anyone figure out the answer for the first part? Okay, what do you got for the position? Okay, 50.625 meters. And what about for the velocity? We'll be quick.
Yeah. 45.
Okay, 45 meters per second. Okay, so all stuff we know how to do. Okay, and then just another quick review. Okay, now this is the one on the actual AP test list of things you're supposed to be able to do. This is the exact question that they say you have to be able to do. All right, it says from a force function, find the change in velocity, which we know we can solve. So the first thing I need to do is do what? What should I do first? Okay, divide everything by 4 to find the acceleration, right? Okay, so the acceleration is the force over the mass. Okay, so that's going to give me, what will that give me then? Go divide everything by 4. 4t squared minus what? 2t plus 1. Okay. All right, so now to get from there to the velocity, what do I do?
Integrate.
Okay. All right, so 4t squared will become what? What does 4t squared become? Okay. 4 to thirds. And then the minus 2t part? Okay, so that just becomes, did I do that part right? Because I don't need, dividing by 2 is going to cancel that, right? And plus, the plus 1 just becomes what? Plus t. And I got to evaluate that from 0 to 1. And what did you get? For this change in velocity?
If they actually ask for the velocity, can you just do the integral of the equation like that for the acceleration? Definitely.
Oh, you need to show your work though, yeah. Okay. So 1.33 meters per second. Okay? All right. So again, this stuff is going to go real quickly when you go back to the WebAssign. Okay? All right. Now, for the next topic, remember the next topic is drag. So the drag forces, remember, these are on your notes, okay? They slow an object down as it passes through a fluid. A fluid can be air. It could be, fluid could be either water or a gas, or liquid and a gas, I should say. They act in the opposite direction to the velocity. They vary with speed vary with velocity or velocity squared, depend upon the fluid and the projectile characteristics. Will impose a terminal velocity if the falling object reaches a high enough speed. Okay, so all stuff we know. It's all there on your notes. Okay, so the general function for drag is this. There could either be either or both of these. And generally speaking, historically, the AP test has only given you one of the two. And of the two, this is the one that they've given the most. Okay, this has only come out, I want to say there have been 9 questions on the AP test, which is, a lot.
Will they give you a coefficient, or will they tell you it varies according to the...
You have to be able to tell from what they give you. Most of the time, they give you the coefficient. Okay. All right. So calculating out the drag force in free fall. Okay. So at first, when the object is first dropped, remember, it's just a force due to gravity. Okay. Then we get the drag force starts to increase as the object falls. Okay. And at some point, when we get to terminal velocity, the drag force is equal to mg. Okay? So let's look at how we end up applying this. So that's when, okay, so for slow-moving objects, we just get bv. Okay? For the faster-moving objects, it's cv squared, where c is equal to all of that. Okay? Doesn't have to be memorized because that would be given to you. Okay? So, for slow-moving objects, this comes up every time that this particular question is on there. You need to be able to show, starting from the force diagram, why this is the case. Okay? Yeah?
So, is oxygen considered a fluid?
Yes, so liquids and gases are both fluids. Okay. All right. So, when we get to terminal velocity in this case, all right, that would be the case where we get the mass times gravity, and in the opposite direction, I would get minus BV as the opposite force. Okay? So I would always start these problems just like we would use our toolkit. Okay, so in this case, so remember downward, and we can call downward positive. A lot of times they use the downward direction as positive, and that's okay. Okay. And then we end up saying mg minus bv is equal to ma. Okay. But when it gets a terminal velocity, what's the really important thing that happens? That you definitely will get, you'll lose a point if you don't say this on your test. Good. The acceleration is equal to 0. So therefore we get mg equaling bv. So the terminal velocity should be what then? Okay, mg over b. Definitely comes up very, very often in solving these problems. Okay?
Why did you start with negative BV?
Because that gives us the force. That's the drag force in the opposite direction. And it's negative because we're going to call it downward positive. Okay?
So what's CV squared?
That's the other version. Okay, so here's what happens. On the AP, so the general equation includes both of them. Okay, but on the AP test, they give you one or another, generally speaking, because they're going to ask you to solve for a differential equation and they want to give you a manageable one, so they either give you one or the other and just set that up.
So technically, like, the force negative force of joint can be equal to BV, and then it can also equal to CV squared.
Yes, but the general equation includes both of them. Okay? Yeah.
The determining factor for slow movement versus fast movement.
Oh, you know what? I have that written down somewhere. Man, I made a point of because I knew someone was going to ask that. It has to do with the ratio of the velocity and the characteristics of there's other characteristics of the object, its size and density and stuff like that. Okay. All right. So remember, this is the so I'm going to put here C whiteboard. Okay, just because I wanted to make sure we wrote this down before. Okay, so on the whiteboard we have the entire setup for this. Okay, so let me hit pause here. Resume this. Okay. All right. So for fast-moving objects, we get this. You know what? I think this is written wrong. I think this should be the square root of the whole thing. Okay, it should be the square root of the whole thing there. Okay, so you also have to show for this setup that terminal velocity is equal to that, and it's the exact same idea. Okay, because we get mg down at terminal velocity, and up we get 1/2 d rho a v squared. Okay. So this is the part that's just called the C portion of it. That's all a constant. So sometimes that's just called C times V squared. Okay. And then we do the same thing. We say the sum of the forces equals the mass times acceleration. Okay. In which case we get a mass. Oh, no, let me write it like this. We get 1/2 d rho a v squared. That's the negative part, plus mg is equal to ma. But then again, at terminal velocity, what happens? Acceleration becomes 0. Okay. So then I can solve this equation to become v is equal to the square root of 2mg, just like we have right there, d rho a. If they give it to you as C, that's fine. Whatever constants they give you, stick with that. Okay? All right. And then everyone agreed, this was just a bonus problem here. This next thing, we're just going to ignore that. Okay? So that would be solving for the differential equation and for the fast moving, for the V squared. And I had